quick countdown. Okay, 5, 4, 3.
This is the third video from Math 141 Finals Review. Given 2 points, we're going to create an exponential function. The first thing we need to have when we're creating an exponential function is our basic equation. We have y equals ab raised to the x. Now, because we have 2 points here, we're able to substitute in for our x and y, which will allow us to solve for our a and our b variables. So I'm going to take our first point, the y is 3 equals ab raised to the negative 2. And for the second point, I'm going to do the same thing. My y is a 2 equals ab raised to the x. I'm going to take my first equation, and I'm going to get b to the opposite side and solve for a. In order to get b to the other side, I need to divide by b to the negative 2, or I can multiply. I'm going to use a different pen for this. I can multiply the side by b to the second power. B to the second power, if you add these exponents together, you'll find that their exponent becomes a 0. So b to the 0 on the right-hand side is the number 1, and we're left with a equals 3b squared. So now I have a term that I can replace a with in the second equation. 2 equals, I'm going to replace my a with 3b squared times b, this x here should be number 3, b cubed. Put our x in and our y in. There we go. And now when we have b squared times b cubed, we add our exponents to get 2 equals 3b to the 5th power. To solve for b, I'm going to first divide by 3. 2/3 equals b to the 5th power. To isolate b, I'm going to raise it to the 1/5 power. This gives me a b to the 1st power on the right, and this to the 1/5 power. Okay. The next step is to put this into your calculator. And when you put it into your calculator, you will get an approximated answer. The best thing to do when you're doing these types of problems is to round to a reasonable decimal place. So this is what I got when I put it in the calculator. I got 0.92210791115. Way too many decimal places for an equation. But I'm going to leave it exact until the very end. I still don't have a value for a. So I'm going to take this b in my calculator, and I'm going to square it and multiply by 3 to get an approximated value for a. So in the calculator, I'm going to do 3 times this number squared, 0.92210791115, the entire thing. I'm not rounding it till the very, very end. And this gives me an approximate value for a as 2.550849,001. Now that I have my numbers and I've used the exact numbers, what I want to do is I want to figure out where is a reasonable place to round these. I'm going to round this one to the 4 decimal places, and this one I'm going to round to 3 decimal places. And so my final equation I guess I'll call this h of x is going to equal my a, which we are saying is 2.55, times my base, 0.9221 raised to the x. This is my function that is an exponential function. Now the points that were given, negative 2, 3, I'm going to put on the graph, and positive 3, 2. This is an exponential function, but you'll notice the base is smaller than 1, but larger than 0. This means it is a decay function. That means it's starting up higher on the right and coming down to the, starting on the left, coming down to the right. This is a decay function. The next step that I'd like to show you is how to find the inverse function. And the inverse function is found by, first of all, switching our x and our y variables. So instead of a y over here, I'm going to put x equals 2.55 times 0.9221, and I'm going to raise that to the y. I want to get y by itself to find my inverse function. The first step is to divide both sides by the 2.55. And that leaves our base and our exponent isolated on the right-hand side. And now, in order to isolate y, I have to take the log of both sides. The first step in doing that is going to be, I'm going to split this up into two separate parts. I know that when I take the log of something that's divided, I can split it up into a subtraction problem. So I can take the log of the numerator and subtract the log of the denominator. And I can also take the log of this number here and pull the y to the front. Y log of 0.9221. So this is the law of differences, where the denominator, you can take the log and subtract it, and the numerator, the log, and adding it. If this were multiplied, I would have a plus sign here of these two logs. Now this number here and this number here, I can actually put in the calculator and get a number to pop out. And I will do that in a minute. The next thing I want to do is isolate the y, so I'm going to divide both sides by this log here. So over on the right-hand side with the log x, I don't really want to put that in the, yeah, I do. Do I want to put it in the denominator? Yeah, I'll put it in the denominator. So I'm going to take log of x, and I'm going to divide it by the log of 0.9221, and I'm going to subtract the log of 2.55 and divide that by the log of 0.9221. All of this is equal to y. This is our inverse function that we can call h to the negative 1 of x. But this is nasty. So we're going to put these into our calculators and come up with some numbers. This is going to give me a number that's a coefficient of the log of x, and this is going to give me a constant. So I'm going to rewrite this function up here. H to the negative 1 of x is equal to, I'm going to start off with this in my calculator, and that gave me a positive 11.54. And when I put this denominator, that's the same as 1 over log of 0.9271 multiplied by the log of x. All I did was take the log of x out of the numerator. This part here is easy to put into the calculator. And when I did that, I got a minus 28.39, and the log of x stays on in the equation. So this is the inverse function to the original function. I'm going to plot those points. This is a log function. This 11.54 is my up and down shift. And this number in front of the log is our stretch factor when we look at transformations. So I'm going to put in the 2 points. Again, you're going to switch your x and your y values. So we have 3, -2, +3, -2, and we have switching our 3 and our 2 here. We get 2, 3, 2, 3. Okay. And so we are going to create the opposite. Inverse function. Thank you.